Lesson 11.1, Writing and Graphing Inequalities. So your goal is to understand how to represent situations that involve not just a single answer, but a range of answers. So let's talk about why we need inequalities. Take a look at the next slide. An inequality is used to describe situations where there is a range of solutions, not just one. All right, so what we're talking about is basically the difference between equations versus inequalities. So take a look at these two problems here. They sound almost the same, but not quite. Here, the band raised $500. Here, the band raised over $500. And so the difference between equations versus inequalities is that this top one we would symbolize with an equation because it only has one solution. In other words, we'd write it something like this, that let's say B, what the band raised, is equal to exactly $500. One answer and one answer only. But for something like this, we're now representing a whole range of answers, what we call a solution set. And so what we have to do is we have to use other symbols to represent this, where B isn't just equal to one thing, it's representative of a whole range of possible answers. And so what we need is symbols that help us describe that, which is where we get inequalities. So here's our inequality symbols. What we have here is less than, or fewer than, the greater than or more than symbol. And then over here, this less than symbol again, but with this little line right here. Well, this little line is basically half of an equal sign. It's saying that our answer can be either less than or equal to this amount. And of course, in English, there's always more than one way to say it. So these are other ways to say the same thing that still relate to this symbol. And then, of course, our last one, greater than or equal to. So these are the symbols that we're going to use in this chapter. We're going to talk about not just single answers, but ranges of answers, solution sets. All right, so let's take a look at this situation. You must be over 12 years of age to enter. So there's not just one age that can enter. There's a whole range of answers I could get here. So to do this, we'd write an inequality. And that inequality would look something like this. If A is the age, then A, as long as it's bigger than or over 12 years of age, they can enter. Now, once you get your inequality, people will ask different questions. Well then, can a 15-year-old go in? In other words, is 15 a solution to this problem? Is it one of those solutions in the range? Well, it's a simple matter of just plugging it in. Is 15 greater than 12? Well, yes, it is. And so a 15-year-old could go in. Now, a different way to ask that, maybe for a different age, it might ask it this way. This is the more mathematical way to ask it. Is A equals 10 a solution? In other words, this is basically saying the same thing as this one. It's asking, can a 10-year-old go in? Well, it'd be the same thing. You plug in 10 for A, and is 10 greater than 12? No, it's not. So no, a 10-year-old could not go in. Now, here's where we have to be careful. What about this question? Can a 12-year-old go in? Well, here we have to be very careful about the wording and the inequality itself. It said you must be over 12 years of age to enter. So if I plug in this 12 for A, I get this statement, 12 greater than 12. Well, is that a true statement? Can a number be greater than itself? Well, no. And so here's where we really have to be careful. The difference between over 12 or 12 and up, it's very important that we pay attention to the wording. And that's where we get into a little bit of trouble with how do we represent that? How do we represent that, in this case, that 12-year-old person can't go in, but somebody slightly over 12 years of age could go in? All right. Let's take a look at the following problem. Your bank account needs to be over $40. So what we'd like to be able to do is to translate this into a mathematical statement. So we're looking at our bank account. So I'm thinking for my variable, I'm going to choose B to represent the bank account. And then our keywords here, over $40. Over meaning I can't just have exactly $40 in my bank account or anything less than that. It's got to be at least $40 and a penny, or $50, or $100, or $1,000,000. But as long as I'm over $40. So for that particular sentence, what I want to do is translate that to be as greater than $40. All right, so now we've got from our sentence in English to mathematical statement. But what if I also want to visually see this? I want to see it as a graph. So let's make a number line. And you know what, since I have to go all the way up to 40, I'm just going to skip by tens. We're going to start here at 0 and go by increments of 10, because that's a reasonable amount where I can still see the details of the graph. Okay, so now anything above $40 was going to be in this region over here. So like, 45, 50, like I said before, somewhere way out to the side, of million here, 100, but anything over here. So essentially we get a bunch of dots in a series where eventually it's just going to become one big long arrow. This represents everything above $40. But then we have a little problem here, because even though we know where this graph came from, what if we showed this graph to somebody else? Well, they might misinterpret this graph. They might misinterpret this graph as $40 or more, because to them this graph starts at 40 and goes up, even though we know we want this graph to start at $40.01 and go up. So how do we make that distinction between something that starts at 40 and goes up, or starts just above 40 but doesn't include 40? Well, the way we do that is we put a dot at the end, and depending on what that dot looks like, we can tell whether it starts exactly right there or just above it. So I'm going to erase a little bit here. And so what we want to do is we want to describe that we're starting just above 40, but not on 40. So the dot we're going to put is an open dot. That open dot represents the fact that we want the graph to start at 40, but not include 40 as its initial number. We want it to start off at $40.01. So when we want it to start above 40, we use an open dot, meaning we're starting at 40, but not including 40. If this had been the other situation in red here, we would have used a closed dot. In this example, we're going to tackle things in a slightly different manner, just to get a different perspective on things. We're first going to translate our situation into the visual graph, and then go to the inequality. So let's take a look at what we've got. The situation says you must be 7 feet tall or shorter to ride the coaster. So in this case, when I go to my graph, first off I need to reach up to 7, so let's do something like this. I'll grab a pen and go from 0 to 7. I don't think I need to skip increments, I can just go by ones. And then I think about what this graph would look like. It says I can be 7 feet tall, so this time I'm going to put a closed dot at 7, because it means that that exact 7-foot person can ride. Anybody taller? No, but the 7-foot person can. And then anybody shorter, meaning anything on this side of the number line. So I create an arrow going this direction. So we have the 7-foot tall person and anybody shorter. So again, notice how I did the dot though. The dot is a closed dot or a solid dot, because what we're concerned about is this misunderstanding here. Is, can that 7-foot person ride? In this case, yes. Now, let's say you had to have been shorter than 7 feet. Well, then this wouldn't apply, and you'd have to use an open dot. So that dot is really important. It's all about whether we're including our starting point as a part of our solutions or not. Now, in this case, we're including the 7-foot person, so it's a closed dot. Okay, so now let's take a look at the rest of it. Let's translate this to an inequality. And the way I always like to think of this is I always like to think of the graph as two different parts. We've got the dot, which indicates the 7-foot person. So the dot itself is representing the fact, let's say our variable is h for height. That is saying the height is, for that person, is exactly 7 feet. Then the arrow is telling us about all the people who are less than 7 feet. So when I come up with my final inequality, it's just a combination of these two inequalities, which is saying that the height has to be less than or equal to 7 feet. All right, so now that we've seen those two examples, let's take a look at these. You can ride if you are at least 4 feet tall. All right, so what I like to think about is I like to think about 3 cases. Can you ride this ride if you are shorter than 4 feet? No. Can you ride this ride if you are taller than 4 feet? Yes. So we're going to have this whole section shaded with an arrow. Now, what about 4 itself? And here's where these last two examples come into play. At least 4 feet tall. So is a 4-foot person at least 4 feet tall? Yes. So we would include the 4-foot person by putting a closed dot. So the 4-foot person can go, and anybody taller than 4 feet. And as far as an inequality, we'd write it as, let's call it H for height. So the height, you could either be greater than 4 feet or equal to 4 feet, and that would allow you to ride this ride. All right, now look at almost the exact same problem. You can ride if you're over 4 feet tall. So ask yourself the same 3 questions again. If you're 4 feet tall, or if 4 foot height is here on the number line, I should say, if you are under 4 feet, can you ride? No. If you are over 4 feet, can you ride? Yes. All right, but then we get this part. You must be over 4 feet tall. So can that exact 4-foot person ride? No. So the way to differentiate it between this situation and this one is here we use an open dot. All right, that way we can tell the difference between whether we're including 4 itself as one of our answers or not including 4, and we're starting at, this would be like 4.000000001. Okay, just past 4. All right, and so that's one of the big things with graphing inequalities is that an open circle represents a solution set that starts at that number but doesn't include that number. All right, so in other words, right here, the number is 12. And let's put a few more numbers in. I usually like to go at least 2 numbers to the left and 2 numbers to the right of the key number, which in this case is 12. And so I want to show all the numbers that are less than 12, but not 12 itself. In other words, my graph needs to include 11.99998, but not include 12. So I need to show that I'm counting all these numbers over here, but not 12 itself. I need to stop at 12, but not count 12. So what I'll do is I'll put an open dot saying that 12 is not included. So the very first number would be 11.99998, something like that. And of course, we don't shade it in. It actually becomes an arrow like this. Okay, as opposed to this one, we use a closed circle if the solution set starts and includes that number. So here, M is all numbers less than and, or, I shouldn't say and, less than or equal to 12. So 12 itself can be an answer. So I want to start at 12, but I also want to include 12. So I'm going to put a closed dot, shade it in, and M can be anything less than that. So again, it's a subtle difference, but it's an important one. All right, so let's wrap up with these 2 sample problems. Graph the following inequalities. So try to graph these 2 in your notes, and if you want to pause the video for a sec, go ahead. All right, so here's how my graph would look. N is all numbers less than or equal to 8. So I start here 8, and then I label a couple numbers above it and a couple numbers below it. And then I ask myself, well, can I include 8 in this? Yes, N is equal to 8. So close dot, and N is also anything less than 8. So an arrow left. So N is less than 8 or equal to 8. So the arrow and the dot. Okay, as opposed to this one, -3. And don't forget on the negative side of the number line, the numbers kind of go quote unquote backwards. So it should look like this. All right, so I want my graph to start at -3, but do I include -3 in the graph? No, there's no equal sign here. X is not equal to -3, which means I'm going to start at -3 but not include it by putting an open dot. But it is everything less than -3. So I'm going to go arrow to the side less than -3. All right, so that's a little bit about writing and graphing inequalities.